Sir, it has high weightage also, right?
Yeah, what happened?
Sir, it has high weightage also, right?
Yeah, yeah. No, but now I think it won't because transistors is removed from the portions. Transistors, communications, that is removed now. So it won't be that much now. Like it will be now, more marks because there nothing is there. Only the diode is there, Zener diode is there, and three types of diodes: solar cell, LED, and all. Only three. Those three. So not much is there. Earlier, like transistor was there, then we could assume like more questions will be asked from this particular lesson. Okay, now we'll start with semiconductors. How did you write the exam, Sayam?
Sir, this exam wasn't counted, was just to get us like into like subjective type of writing.
Mm-hmm.
So like I only studied around 2, 3 chapters for this exam
Okay,
because
okay,
they weren't asking much anyways. So yeah. Though 2, 3 chapters which I studied, I did well. Others I didn't do.
okay, okay. Good. Anyways, so in semiconductor, see, semiconductors means the completely it is the electronics. Okay, it's completely related to the electronics. Now we'll go with the classification of metals, conductors, and insulators. So first we'll start with these are the different types of metals. Metals means they allow there is a flow of current. When we apply potential difference, there is a passage of current or there is a flow of current. So flow of electrons is there in metals. Example for this is copper, aluminum. These are the examples of metals. Next one is uh, insulators. Insulators means which do not allow the no passage of current. No passage of current. No passage of current. Those are said to be the insulators. Example for that is what rubber and wood. These are the example. These are the examples of insulators. Okay. Third one, we have semiconductors. You know the dielectric material which you studied in your grade, sorry, in term one. Dielectrics. Dielectrics means best example for this is glass and mica. Glass and mica. These are the example. But what is dielectric? It has dipoles. It has dipoles. Okay, polarity is there. So when you place this type of material in presence of electric field, all the dipoles will be aligned. Okay, all the dipoles will be aligned properly. In the all the dipoles will be aligned. So this particular concept is said to be dielectrics. Okay, this particular concept is said to be dielectrics. Now next one. So next is fourth one, and one more thing. Keep that in the mind. All dielectrics are insulators. All dielectrics are insulators. All dielectrics are insulators, but not all insulators are dielectrics. Okay, not all insulators are dielectrics. Not all insulators are dielectrics. Okay, so this is about dielectrics. Next one, all are dielectric material. Next is semiconductors. Semiconductors means which will allow very small amount of current. When you apply potential difference across the material, then where there is a very small passage of current. Okay, so that is it allows very small flow of current. Very small, very small flow of current. That is said to be semiconductors. Example for semiconductors is what? Silicon and germanium. Example for semiconductors is silicon and germanium. Okay, so now we'll discuss about that in detail now. Very small amount of current will flow, and there is one more material that is said to be superconductors. It's not the part of this, but you should know what is the difference, because one should know what is the difference between all these material. Superconductors means resistance is equal to zero. Resistance of the material is equal to zero. Means current is constant. that type of material. Resistance is equal to 0. Such type of material is said to be superconductor. That will happen at very low temperatures, around maybe 4 Kelvin, means which is equal to minus 269 degrees centigrade, which is not possible at room condition, that is normal conditions. We need very high pressure and many situations are there. So only at that point we get these superconductors. Okay, so we have superconducting wires. We are going to, like US is working on this to form superconducting wires. If superconducting wires are there, then we can save a lot of electricity. Around two-thirds of electricity is wasted in transmission. Around two-thirds of electricity is wasted in transmission. So if once the superconductors are developed, if we are able to gain or if we are able to manufacture superconductors, superconducting wires, then then what we can do, then we the current will be saved. Instead of lighting one city, you can go with 3 cities. That much electricity we can save. But still, it is under research. Okay, now, but how will you compare this one? We only can compare with resistivity and conductivity. What is resistivity or specific resistance? Any idea? Resistivity or specific resistance? Resistivity or specific resistance. Okay, resistivity or specific resistance. What is the meaning of this? So we have the formula, no? R is proportional to, we learned this, R is proportional to L, R is proportional to 1 by A, then we wrote R is proportional to L by A, then we wrote R is equal to rho into L by A, then what is that? Rho is equal to what? Rho is equal to R into A by L. This is the formula for resistivity. Understood now? So what is the meaning of this? Resistance of a wire of unit area per unit length. Okay, resistance of a wire. So resistance of a wire of unit area per unit length, Now what is the unit of resistivity? Ohm meter. Okay, ohm meter. This is the formula for or we can write ohm meter, unit of resistivity. Next is conductivity. What is conductivity? Conductivity is reciprocal of conductivity sigma. Okay, reciprocal of resistivity. Reciprocal of sorry, reciprocal of resistivity is said to be conductivity. Reciprocal of resistivity is conductivity. So we are writing sigma equal to 1 by rho. So what is the unit of resistivity? Unit of resistivity is Siemens per meter. Siemens per meter. This is the unit of resistivity. Now, or mho per meter, MHO, mho per meter. So generally, what is that? Conductivity means reciprocal of resistivity, or we can also say conductivity means uh, it's a property of the material which allows. It is the property of the material, which allows the passage of current, which allows the flow of current. Understood? So this is said to be the conductivity. Now we will discuss about what are the values for metals, semiconductors, and insulators. Metals, semiconductors, and insulators. Now, is it clear, all of you? Is this clear? The resistivity. See once again, what are the metals? Metals means which allow the flow of current or passage of current. We can say flow of current or electrons. Those are metals. Example for that is copper and aluminum. Insulators, they don't allow any passage of current. Rubber and wood is example. Dielectrics means glass and mica. An example is like they are actually dipole, they are having dipoles. Now, when you place this type of material in presence of electric field, they align themselves in the direction of the field. So, there is a statement: all dielectrics are insulators, but not all insulators are dielectrics. Fourth one is semiconductors. It allows very small flow of current. That is like example is silicon and germanium. Next is semiconductors. It allows very superconductors means resistance of the wire is equal to 0. That means current is constant. And T is equal to what? 4 Kelvin. That is the value of superconductors. Next one is resistivity. Resistivity or specific resistance. Means what? When means R is directly proportional to L. As the length increases, resistance increases. As the area of the conductor increases, resistance decreases. To remove this is a proportionality. R is proportional to L by A, or R is equal to rho into L by A. Now R is equal to rho into L by A. Uh, so here we have conductivity. Next is what? Reciprocal of resistivity is said to be conductivity, or it is a property of the material which allows flow of current, is said to be conductivity. So it is the mean unit is Siemens per meter or mho per meter. Next one. Mho per meter. Next one is, now we will discuss about the metals resistivity and conductivity. Earlier he used to ask, but I don't know now whether he will focus this on this or not. Rho value is equal to for conductor is 10 to the power of minus 2 to 10 to the power of minus 8 ohm meter, and resistivity is 10 to the power of 2 to 10 to the power of 8 Siemens per meter. Coming to insulators. What is the value? The value for insulators is rho equal to how much? 10 to the power of 11 to or 10 to the power of 19 ohm meter, and sigma value is equal to how much? Sigma value is 10 to the power of minus 11 to 10 to the power of minus 19 Siemens per meter. And next is semiconductors. What are semiconductors? In semiconductors, what will happen? In semiconductors, so rho value is equal to 10 to the power of minus 5 to 10 to the power of 6 ohm meter, or sigma value equal to how much? 10 to the power of 5 to 10 to the power of minus 6 Siemens per meter. This is semiconductors. Okay, this is about the semiconductors. Next is what? uh, how is the classification taken place here? Elemental semiconductors, compound semiconductors, that we will see. See the classification how it is. The classification is semiconductors are classified into two. What is I am? After a long time, we have uh, intrinsic and extrinsic semiconductors. Okay, intrinsic, sorry, intrinsic or pure semiconductors, and the next one is extrinsic or impure. Extrinsic or impure semiconductor. Pure is what? Example for intrinsic pure intrinsic is what? So we can write silicon and germanium. And for extrinsic there are two, that is p type and n type. P type semiconductors and n type semiconductor. P type and n type semiconductor. This is the classification. Next one. So now we will go to the organic and inorganic compounds. So compound semiconductors. So what are the compound semiconductors? See, are you understanding this one? So these values you have to remember: metal, insulators, and at least you should have an idea. Okay, so keep that in the mind. For metals, resistivity is in power negative and conductivity is positive. Whereas for insulators, it is completely opposite. Sigma, that rho is or 10 power 11, then sigma is 10 power minus 11. Whereas semiconductors, it is in between metals and insulators and metals. Next one, classification of semiconductors. So we have pure and intrinsic and extrinsic. Pure means intrinsic, extrinsic means impure, and in that we have P type and N type semiconductors. Next one is compound semiconductors. compound semiconductors. Now here, so the first one is what? Inorganic. Inorganic is what? Cadmium sulfide, gallium arsenide, gallium selenide, and indium phosphide. These are the examples of inorganic compounds. Next is organic. Organic compounds, what are they? Anthracene. Anthracene is an example, and doping. I will tell you what is that. What is it? Cyan. Okay. Halocyanine. Cyanine. This is example. Okay. Next one is organic polymers. Organic polymers. These are the examples. What are they? They are polypyrrole, polyaniline, and polythiophene. These are the examples. Okay. Next comes, that is how the classification is taking place. Now we'll discuss about valence band, conduction band, and all. Okay, what is valence electron? What is conduction electron? Is it clear, this one up to here? Any doubt? Intrinsic we wrote here. Organic classification, compound semiconductors. These are all compound semiconductors. Now next one. Next one is, so we'll start with the core electrons. What are core electrons? What are core electrons? There are no derivations, my dear. You can just enjoy, sit and enjoy. Okay, just tell me what is a core electron? Core electrons. Electrons which are close to the nucleus. Electrons which are close to the nucleus. Electrons which are close to the nucleus is core electrons. Then what is valence electron? Valence electrons means electrons which are in the outermost orbitals. Electrons which are in outermost orbitals. Electrons which are in outermost orbitals. Electrons which are in the outermost orbitals. That is said to be a valence electron. Okay. Now, what is a band now? Okay, we'll discuss about a band now. What do you mean by band? Is it clear? So core electron means which are very close to the nucleus, and valence electrons means which are away from the nucleus in the outermost orbitals. Next is valence band. We'll start with valence band. What is a valence band? Valence band means the band formed due to the valence electrons. The band formed due to the valence electrons. The band formed due to the valence electrons is said to be valence band. Okay, is said to be valence band. Means, like suppose in one atom, if there is one electron, for million of atoms, how many electrons are there? The possibilities like million of electrons will be there. Like in one atom, if there is one electron in the valence shell, then there for million atoms, if you take, million electrons will be there. So that is said to be valence band. Okay. So we have valence electron and valence band. Next is conduction band. Next is conduction band. Okay. The next higher band of valence band. The next higher band of valence band is conduction band. Okay, the next higher band of valence band is conduction band. So if the current has to flow, the electron has to come to the conduction band. Okay, next one is what? Forbidden band. Okay, forbidden band or forbidden energy gap, or forbidden energy gap. Forbidden band or forbidden energy gap. So what is forbidden band? The gap the gap between valence band and conduction band. The gap between valence band and conduction band. The band between the valence band and conduction band is said to be forbidden band, okay, or forbidden energy gap. Example, like suppose if I am taking the energy level diagram, we say this is said to be energy level diagram. Energy level diagram. If you are drawing energy level diagram for conductors and all, conductors, insulators and semiconductor. So this is the energy, electron energy. What is the energy? Energy of the electron. Now if I am taking for conductors, in conductors what will happen? This one and this one both will overlap like this. Okay, that means the valence band and the conduction band, they overlap. This happens in conductors. Okay, in conductors what is happening? Valence band and conduction band overlap. Conduction band overlap each other. Okay, valence band and conduction band overlap each other. Next one is what? The next one is what? Suppose this is the energy. Now we have two bands here. This is one band and the next one is here. So this is valence band and this is conduction band. So what is happening? There is a gap. This gap is said to be energy gap or forbidden energy gap or energy gap. Forbidden energy gap or energy gap. So in this, what is happening? Suppose in semiconductors, if you are speaking about semiconductors, so little energy is required, so that what happens, the electron will go from here to here. If you give energy, then only the electron which is here in valence band will jump to the conduction band. Here is not required, no energy is required, just apply the potential difference, current will flow, because the valence band is overlapping with the conduction band. Not much energy is required, there is no energy required, there is no energy required for the electron to move from valence band to conduction band, because already electrons are ready to move. Electrons are ready to move. Now that happens in semiconductors. Okay, now the gap is said to be energy gap. So what will happen for semiconductors? It is less than, the energy gap is less than what? Is less than 3 electron volts. Okay, it is less than 3 electron volts. Here what is the energy gap? Energy gap is equal to 0. No energy gap. Is that clear? This happens in the conductors, this happens in the insulator semiconductors. Next one is what? This is the energy. Now so this is a band here. Okay, so you can see this is a band means what? The in simple, band means a band in simple words, how will be explained? It is due to the, all the orbitals or all the electrons in the valence level. Okay, so instead of saying, suppose for one electron, if there is, suppose for one atom there is one electron in the valence shell, there for million electrons there will be million atoms, there will be million electrons. So instead of saying like every time that many electrons, we are saying band. In simple words, we are saying band. Okay, so valence band means the band formed due to the valence electrons is said to be valence band, but it doesn't mean that when I apply potential difference, current will flow. No, the electron has to come to the higher level, then only conduction band, then only electrons can free flow of electron will take place. So now this is valence band and this is conduction band. So the energy gap is large. Here the energy gap is more than 3 electron volts. So it requires a lot of energy to, it requires a lot of energy for that. So energy gap is more than, greater than 3 electron volts. Okay, so that happens. Now we will quickly discuss about what is a pure semiconductor and impure semiconductor and how they are formed. Is it clear? First of all, is it clear? Yes. In the textbook he draws in a different way. In a textbook, in the textbook he is drawing the same thing in a different way. Okay, just he's taking just the energy. Okay, he's taking the energy. Okay, anyways, now I'm going to the third group, fourth group, and fifth group semiconductors. Okay, suppose conduct material. We have 3A group elements or 13th group elements. What are 3A group elements? Any idea? Boron, aluminium, gallium, indium, and thallium. Thallium is a radioactive substance. Next, fourth group element. What are the fourth group? 14th group we say. Fourth group means also known as 14th group. Carbon, silicon, germanium, tin, and lead. Pb. Fifth group element is also known as 15th group element. What is that? Nitrogen, phosphorus, arsenic, antimony. Uh, Antimony means what? Sb. Antimony, bismuth. Here, boron, carbon, and nitrogen are gases. Thorium, thallium, lead, and bismuth is they are radioactive elements. We have to only go with these three elements only. Now 1, 2, 3, and 1, 2, 3. Only these elements will play important role while understanding this third group for that is p type and n type. Now, if I speak about a pure semiconductor, okay, so we'll see what is the formation of p type material. Or before that, I will go with n type material, so it will be easily understood. N type semiconductor. N type semiconductor. In n type semiconductor, what is the combination? The combination is a 14th group element. There is a doping between 14th group element, fourth group element with the fifth group element. Okay, 4A with 5A. Now, what exactly is happening? Like suppose there is a carbon. Suppose carbon is having 4 electrons in the outermost shell. Okay. Now there is one more. This is said to be tetra. This is sorry. This is tetravalent. Carbon is tetravalent. Or we can take. I'm taking B. Okay. For our this one. So suppose A is what? A is it is having 5 electrons in the outermost shell. It is having 5 electrons in the outermost shell. Now we are this is B again. This is again B, and again this is B. Means what is happening? This will combine and form a bond. This two will combine and form a bond. This two will combine and form a bond, and this two will combine and form a bond. So this is what? This is the extra electron, excess electron. Understood? This is said to be the excess electron, because of which the current will flow. So that is why it is said to be n-type semiconductors. So in n-type semiconductors, the charge carriers are what? In n-type semiconductors, the charge carrier. The charge carries electron. Okay, for n-type semiconductors, the charge carrier is electron. Next is p-type semiconductor. In p-type semiconductor, there is 4A group element with dope with the fifth group element. Sorry, third group element. So what will happen now? Suppose there is X one element who is having 3 electrons in the outermost. Okay, there is not 4, there are only 3, like trivalent. This trivalent, when we are doping the trivalent with tetravalent, we get p-type semiconductor. So Y is what here? Y is what? Having 4 electrons. This is also having, this is tetravalent. This is also same, tetravalent. So now what happens? This will form a bond, this will form a bond, and this will form a bond. So what happens? There is a hole here. This is said to be hole. Okay. Now p-type semiconductors, the charge carrier is whole. Charge carrier is whole. Okay, before that, I will just explain that what is doping, then I will go with what is hole. Doping means addition of impurity to a pure semiconductor. Addition of impurity to the pure semiconductor. Addition of impurity to a pure semiconductor is said to be doping. Now, what is a hole? Hole is a vacancy part of electron. Vacancy part of electron. That is said to be hole. Understood? Is it clear all of you? See, once again, we have third group element that is also known as 13th group element. Boron, aluminum, gallium, indium, thallium. Boron is a gas and thallium is a radioactive element. Similarly, for a 14th group that is carbon, silicon, germanium, tin lead. Fifth is 15th group element sodium, nitrogen, phosphorus, arsenic, antimony, and bismuth. So next we have here, and here these are all the gases and these are the radioactive elements. Okay, these are the gases and these are the radioactive elements. So only we use the middle ones. N-type semiconductor is what? So actually, why they actually remote see what these people are doing, when they did not get radioactive elements from the nature, so they took like boron, like the gases, and they want to they want to start the process of fusion reaction in the lab. So that's the reason. And also there is a gas, boron, carbon, and nitrogen are gas also. N-type semiconductors. So in N-type semiconductors, fourth group element is matched with fifth group element. Means what? If A is having 5 electrons in the outermost shell and B is having 4 electrons in the outermost shell, they combine and form a bond. But this electron is said to be the excess electron. Similarly, in N-type semiconductor, the charge carried is electron. So and P-type semiconductor, what is happening? Fourth group element is matched with the third group element. So what happens here? X is having one less electron, one less electron. So that is denoted by hole. And Y is having all 4 electrons. So what will happen? It will combine with all the three, but it could not combine because there is a the hole is left over. So P-type semiconductor, the charge carriers are holes. And what is doping? Dopation, addition of impurity to a pure conductor. Addition of impurity to a pure semiconductor is said to be doping. Is it clear? Yes, sir. Is this clear? Yes, mister. Is it clear? For N-type semiconductors, what will happen for N-type semiconductor? This is the condition. Number of electrons is much greater than number of holes. Okay, number of electrons are much greater than number of holes. But in P-type semiconductor, number of holes are much greater than number of electrons. So one can easily understand with the concept of electrons, but we cannot understand with respect to holes. Holes means what? Vacancy part of electron is said to be holes. Vacancy part of electron is said to be holes. Suppose you were sitting on a chair and I told you, I forced you, get up, I want to talk to you. Then you created a whole space over there on the sofa. So someone else can come and sit there. Understood? Is this clear, sir? Yeah. Now, we'll go to PN junction diode. Okay, PN junction diode I will not teach now. Okay, I'll teach tomorrow. Is it okay with you? PN junction diode, Zener diode. What time I have to take tomorrow? Can you please tell me? For the next 3 days, Friday, Saturday, Sunday. Please tell now itself. I'll fix the time and we can go with that. Yes, sir. What time you suggest? For next 3 days, Friday, Saturday, and Sunday. Okay, yes, I will stop the meeting.